Welcome back. In today's lesson, we are going to discuss about the graph of force against extension of an elastic material. It can also be called a curve of force against extension, and in some textbooks, this relationship can be shown by using stress against strain. The relationship is the same explanation. So we can just move on directly to explain about how force changes with extension. As you can see, there are different points indicated on the force extension curve. Point A is known as the limit of proportionality. And what you can immediately observe from this point A to the origin point O is a straight line. This explains that the more force you apply, the more the extension. The more force you apply, the more the extension. So that is called the limit of proportionality. Then we move on to point B. Point B is known as the elastic limit. The elastic limit is defined as the maximum force that can be applied to an elastic object, and then the object will be able to restore its original size and shape after the force is removed. The elastic limit is the point where the object can return back to its original size and shape after the force is removed. So it is the point below which the material behaves elastically, but beyond which it begins to behave as a plastic, meaning that the object no longer restores its original size or shape. So this point is very, very important, because if the elastic limit is exceeded as explained by the Hooke's law, then the object is no more going to have a force that is directly proportional to the extension. Remember, the law states that provided that the elastic limit is not exceeded, the applied force is directly proportional to the extension. So this point is so critical for the fact that if I apply any force and then the force is removed, then the object will be able to restore its original dimension, which means the size and the shape. You can also explain it this way, that the elastic limit is the point beyond which an object begins to behave as a plastic, or you can explain it as it is the point beyond which plastic deformation begins. Remember, we said that a plastic deformation is a type of deformation in which the object does not restore its original size and shape even after the applied force is removed. Moving on to the third point is called the yield point. The yield point is that point beyond which any applied force results to a very large extension. So if an elastic object is subjected to a force beyond its yield point, it produces an extension that is too much for that small amount of force. So if an elastic object is subjected to a force beyond its yield point, the extension that it produces is very, very large. That is not proportional to that given amount of force. So meaning the small force produces very large extension. That only occurs beyond the yield point. Remember the yield point as the point beyond which a small increment in the applied force results to a large increment in the extension. The next point to discuss is known as the ultimate tensile strength. It is the maximum force that can be applied to an elastic object without breaking it. Okay? So the ultimate tensile strength is the maximum force that can be applied on an elastic object without it breaking. The ultimate tensile strength can also be defined alternatively as the maximum force that can be applied on an object beyond which the object undergoes breakage. Point E is known as the breaking point. So it is the point where the elastic object cuts or breaks. Going over the explanation for the force extension graph, we said that point A is known as the limit of proportionality. So between O and A, the object will be able to restore its original size and shape whenever the applied force is removed. So between O and A, Hooke's law is strictly obeyed. Hooke's law is strictly obeyed. Okay? Because the elastic limit is not exceeded. Okay? So any point here, the object will be able to restore its original size and shape whenever the applied force is removed. The elastic limit is the point beyond which an applied force will cause an object to undergo plastic deformation. So it means it is still the point below which the object will be able to restore its original size and shape. Then what we can say here is all the way this point, the object will undergo elastic deformation. But beyond the elastic limit, an applied force will cause the object to undergo plastic deformation. So this region here, we have plastic deformation, meaning that all the forces applied on the object will cause the object not to be able to restore its original size and shape. That is known as plasticity. So beyond the elastic limit, an object no longer behaves as an elastic body. The yield point is that point where a small amount of an applied force will result to a larger extension. The ultimate tensile strength is the maximum force that can be applied on an elastic object without causing it to break. So which means The ultimate tensile strength is the point beyond which an object will undergo breaking or it will cut. So the point E is known as the breaking point. The definitions are stated here once again. We can quickly read them because we have already made the explanation. The limit of proportionality is the point beyond which the extension is no longer proportional to the applied force. So Hooke's law is obeyed before this point is attained. Elastic limit is the point beyond which the applied force results to permanent deformation. It is the point at which the maximum force applied to an elastic body can still cause the elastic body to return to its original size and shape when the applied force is removed. So the elastic limit is very important to know. Moving on to the yield point. It is the point beyond which any small increment in the applied force results to very large extension. The ultimate tensile strength is the point beyond which any further increment in the applied force results to breakage or cutting of the material. And then we move on to the breaking point. This is the point at which the material no longer can withstand the applied force, resulting it to break or fracture. That is all for today. In our next lesson, we will be talking about the gradient of force against extension. If this is the first time of visiting this channel, please subscribe, like, and share the video. Subscribing to this channel means a lot to us. Thank you very much.